we've looked at all the different trig ratios and we've worked on finding reference angles. So now we're actually going to practice some evaluating the trig functions at any angle. All right, so this box here gives you the basic process that you go through when you're trying to evaluate the trig functions of an angle that's sketched in standard position. So the first thing you're going to do is have to find the reference angle, right? And we had talked about how you find the reference angle for any angle in the different quadrants. Determine whether the trig functions are positive and negative, which ones are positive and negative based on the quadrant, and then just use the reference angle to determine the trig ratios, and then change the sign if appropriate, right? So it's pretty straightforward. The key is really finding the reference angle first, and then basically using our special triangles. So find the sine of 16 pi over 3. All right, well, first things first. 16 pi over 3. See, some of these are all worked out already, but sometimes it's not obvious how you knew that 16 pi over 3 was coterminal with 4 pi over 3. So the way that they get from 16 pi over 3 to 4 pi over 3 is they realize, well, 16 pi over 3, if I that's wrapped around the circle a few times. So if I subtract, let's say, 12 pi over 3 from this, right, which is really 4 pi, right? 4 pi is 12 pi over 3. I arrive at 4 pi over 3. So really what you're going to sketch is an angle 4 pi over 3, right? And 4 pi over 3 ends up being in the third quadrant. But then what happens is you realize, hey, well, in the third quadrant now, how would I get that reference angle? Well, we had talked about this, right? You're doing the whole angle, which is theta, minus pi, right? Minus 180, which is pi. So you're going to do the reference angle. Theta bar is going to be the whole angle, so 4 pi over 3 minus pi, which is really 3 pi over 3. So you're going to end up with pi over 3, right? So 16 pi over 3 has a reference angle of pi over 3. And then also now, so you're in the third quadrant, so if you use your ASTC, that means that tangent is negative. So we want to find I'm sorry, tangent is positive. We want to find the sine. So sine is actually going to be negative in this third quadrant. So what we're going to have is we're going to have that the sine of 16 pi over 3 is not going to be the same as the sine of pi over 3. It's going to be the opposite of the sine of pi over 3, right? Because sine of pi over 3 is going to be positive, but we want the opposite of that, right? Because we know sine is negative in the third quadrant. So then what you're going to do is you're just going to go to your special triangle, right? And you're going to say, all right, well, my special triangle, if this is pi over 6 and that's pi over 3, right? Pi over 6 is the 30-degree angle. This was 1 square root of 3 and 2. So the sine of pi over 3 is going to be the opposite over the hypotenuse. So it's going to be square root of 3 over 2. But like I said, it's going to be negative because it's in the third quadrant where sine is negative. So the sine of 16 pi over 3 is really going to be negative square root of 3 over 2. Right? And that's the process that they go through there, which is the same as I just did. And then to do negative pi over 4, well, negative pi over 4 isn't terrible because to get the reference angle, just realize, all right, well, if this is negative pi over 4, the reference angle is the same, it's just positive, right? So that's fairly straightforward to see because, yes, this is the fourth quadrant angle, but you're not thinking of it that way, right? You're thinking of it as a negative angle. So the reference angle is really just positive pi over 4. So that's pretty straightforward, I think, to see. So then what you realize is, all right, well, we're in the fourth quadrant and we want the secant, but the secant is the reciprocal of the cosine. So the secant is actually going to be positive because cosine is positive in the fourth quadrant. And then what you do is you just realize, all right, well, the cosine of negative pi over 4, it's actually going to be the same as the cosine of pi over 4. Right? And then again, we'll go with our little triangle. And in this case, it's the 45, 45, 90, right? Which is pi over 4, pi over 4, and we had called these the legs 1 and the hypotenuse square root of 2. So the cosine of negative pi over 4 is the same as the cosine of pi over 4, which is going to be adjacent over hypotenuse, which is 1 over the square root of 2. But again, usually when you do these, they're going to rationalize the denominator by multiplying by radical 2 over radical 2. So then you're going to end up with square root of 2 over 2. So that's going to be your cosine of pi over 4, but we want the secant. So it's really 1 over the cosine. And when we flip this, actually, we would get 2 over the square root of 2. So actually, in this case, it made sense not even to rationalize the denominator, right? We could have left it at 1 as 1 over the square root of 2, and then when we take the reciprocal of that, we end up just getting square root of 2. Because look what happens now when we try to rationalize this. Multiply by radical 2 over radical 2, and we're going to end up with 2 radical 2 over 2, but then the 2's cancel, and we just end up with the square root of 2. So it would have been easier, actually, just to stop here and just realize, hey, we're doing the reciprocal of the cosine, therefore we're just going to flip it and we're going to get the square root of 2. So that was the more straightforward way to do it. Okay, and they dealt with secant from the beginning. Right? Now it's probably not obvious how they got that, but if you look back at my previous work, it's probably a little bit clearer. All right, so maybe we'll do a couple more of these. So let's say you wanted to find, what did we do? We did a secant and we did a sine, maybe. So let's say you wanted to find the tangent of, I don't know, 5 pi over 6. All right, well, 5 pi over 6 is actually going to be in the second quadrant. So 5 pi over 6 is really this. But remember what we do, we want this reference angle, which we're calling theta hat. So the reference angle is going to be 180, right, or pi, minus 5 pi over 6. So our theta hat in this case, theta bar, sorry, is going to be pi minus 5 pi over 6. And that's 6 pi over 6 minus 5 pi over 6, so it's going to be pi over 6. And now we're in the second quadrant, right? So if we do ASTC, sine is positive, tangent is going to be negative. So we're going to say the tangent of 5 pi over 6, it's not the same as the tangent of pi over 6, it's going to be the opposite, because it's negative, of the tangent of pi over 6. So we would, again, we would go to our 30, 60, 90 triangle. Right, so opposite the pi over 6 is 1, adjacent to pi over 6 is square root of 3, and the hypotenuse is 2. So if we did the tangent of pi over 6, it's opposite over adjacent. So it's going to be negative 1 over the square root of 3, right, because it's in the second quadrant. But then this is negative, and again, multiply by square root of 3 over square root of 3, and you would just end up with radical 3 over 3. So it's negative square root of 3 over 3. So that would be your tangent of 5 pi over 6. And then maybe let's look at one more here. Let's say we were going to do the cosine of 7 pi over 4. All right, well, 7 pi over 4 is in the fourth quadrant. So this is 7 pi over 4. So remember, how would we get our theta bar? it would be the whole circle, right, which is 2 pi minus 7 pi over 4. So theta bar is going to be 2 pi minus 7 pi over 4, which is going to be pi over 4. And then if we look at ASTC, we realize, hey, the cosine of 7 pi over 4 is actually going to be the same as the cosine of pi over 4, because cosine is positive in the fourth quadrant. So it's going to be the same as the cosine of pi over 4. And the cosine of pi over 4, if we remember, again, our triangle, and eventually you won't have to write this out every single time, right? You have 1 square root of 2. The cosine of pi over 4, adjacent over hypotenuse, so it's 1 over the square root of 2. But again, rationalizing, we end up with square root of 2 over 2. So the cosine of 7 pi over 4 is actually the same as the cosine of pi over 4, which was square root of 2 over 2. And what you might have realized with these is when the denominator was 4, our reference angle always ended up being pi over 4. And that's always going to be the case. And in the last one, our denominator was 6. So when we have that, our reference angle is always going to end up being pi over 6. And then similarly, let's say we were doing the sine of 4 pi over 3, which we might have done before, right? 4 pi over 3 is this. What ends up happening? This ended up being our theta bar, and our theta bar ended up being 4 pi over 3 minus pi, which ended up being pi over 3. So what ends up happening is when our angle has a denominator of 3, our reference angle always ended up being pi over 3. So that was a nice little trick that you can remember that'll help and that'll be useful moving forward.